Alright, so I'm hopeful that I've haven't messed up my settings and everything works fine. So yeah, hello everyone, welcome to this video. And in this video I'm going to show to you something that I've done. It's MQr1.1 or MQr11 as I call it because easier to pronounce. So here I have a simple, tiny little computer. And this computer currently has a very boring program in it, in fact, which I'll speed up a little bit by doing this magic. I'm just gonna transfer these because those were no op operations. I don't need to know what happens, but yeah, it just doesn't matter. And Halt can stay here because we're doing a jump there, so it doesn't matter. So yeah, what this program will do is we'll count from 255, included 255, down to 0, including 0. So yeah, this is basically just a for loop, and each time, currently I have a very, because I don't have like, and yes, I'm using quick logic because I don't want it to take tens of years, or probably like half an hour, I'd imagine. I don't think it will take that long. But anyway, uh, currently I did a very hacky solution to how to connect a screen right here. Very hacky because what we're basically doing is just directly grabbing the data from this memory address, from 0th memory address, and plopping it into the screen. That's it. Of course, that's not how it will be done in the future. Of course, I'll add something cool as actual expansion ports, and also, in fact, I'm very much planning to add direct memory access, DMA, the most overpowered thing that the computer can have, really. I'm hopeful that I'll be able to add it, yeah. So the current speed on this computer, just without any speedups, on average, it's 2.7 instructions per second. With a speed up, I've said that it's 8,000, but that's, I think, basically a complete and utter lie, because I don't think it will work fine at 2.8 thousand, or 2.1, 8.1 thousand times the speed up. Mostly because I was testing it without the screen. Right now I'm testing it with the screen, and the screen is, well, it's not one block, obviously. It's pretty optimized. It's just 800, but still, that's 800 more to process for the logic and Lua scrap mechanic bullshit. So yeah. But anyway, let's just run the computer and see what happens. I'm gonna actually, I can do this, which is pretty cool. I can just connect the button to here, and it will just work, you know? Pretty cool. So theoretically, currently what speedup we have is, let's see, just 1 times the speedup, aka no speedup at all. So it's just basically vanilla logic speed. And as you can see, here it counts. I actually didn't expect how fast it will count. Okay, I thought it will take much longer, but it actually does it very quickly. Holy. Granted, it's just a for loop with decrements in it, so of course it will be extremely fast. There's like, yeah, duh, it will be fast. But yeah, before I had like 3 no-op instructions here, right? Like right here, well, right here, and right here. There were a bunch of no-op instructions, so that's why it took so long to actually calculate. Well, quote-unquote calculate. And here we don't do anything. We just basically do a for loop, and you can see how fast the for loop actually goes. I could unwrap the for loop, I guess. The computer should theoretically be able to handle 64 kilobytes, or kbytes, if you want to be precise, kbytes of ROM and cache, so it will be fine, but I'm not gonna do that. Yeah, that just does that. Let's just speed up that thing. Actually, I can place multiple buttons if I'm not mistaken. And let's just see how fast. So 2 times speed up, 4 times, 8 times, 16 times, 32, 64, 128, and it starts to really struggle. But it's damn fast. It's damn fast, mate. It's a very, uh, oh shit, the button doesn't work. Ooh. Okay, yeah, I guess one press here literally means 128 tick to, like, press. So I'm not surprised that it doesn't quite work. Okay, let's do that. Let's clean it. So yeah, it's a pretty fast computer. Uh, yeah, uh, it can go 128 times this normal speed. It will start to, it will drop to like, I have no idea how many FPS, probably around 10. No, that was more than 10. Around 20. Let's say 20 FPS. It drops to 20 FPS with 128 times the speed up. And I don't think it really matters, like my hardware. It's okay-ish hardware, I think. But I don't think it matters because it's basically down to scrap mechanic, single core, single thread bullshit with Lua. Like Lua is being ran on one core. That's basically it. So we have one fucking core to spare. That's dog, mate. That's a lot of performance lost. I would imagine if if scrap mechanic were using all my cores, this thing would be able to run at fucking gigahertz speed. Okay, probably not gigahertz, but pretty darn fast. Like the say, and it like scrap mechanic could become the next logic world, but it doesn't because I don't know honestly what's wrong with Axolot. Come on, guys, you can do it. I believe in you. Like, just please make the Lua thing run multi-core, and that's it. You literally will allow so much more stuff. And also, like, compile the stuff. Like, compile the Lua to C or something. Like, compile it. That would allow for so many things. That would be incredible. But unfortunately, no. I don't know what's wrong with Axolotl games. Like, what are they doing really? Are they, like, struggling? I would imagine probably yes, but that's just very unfortunate. The game is great. I still play it. I've played it for 2.3, I think, thousand hours at this point. Like, that's a great game. I love it because making computers in it is fun. But unfortunately, the Axolot games, it's just, I don't know. Let's hope at some point, maybe someone will create a multi-threaded, compiled logic simulator. And I know Logic World exists, but I'm still very salty about the fact that I cannot cannot do connections through walls. I've just realized I'm talking into my nose. Excuse me. Okay, let's just speed up that. Oh, 512. Yeah, fuck it. Let's speed up 512 times. I thought it was at the same speed, but no. 512. Let's see how fast it will go. Yep, that's pretty fast. That's kind of unusable though. I mean the scrap mechanic frame rate, because what is this? Like that's funny. Oh, it actually cleared. What? I don't know how it did it, but it did. I think the 16 times speed up will actually work. Yeah, here's the 16 times the speed up. That's... Oh wow, that looks... that looks funny. Damn. You can see here's the 0th memory address, and yeah, that's honestly pretty funny looking. I like it. You know, I think I could make this computer run faster with Levin links. Because right now the speed is actually fine. I think the screen without the sped up logic could actually keep up, alright? I would be able to do that. I have to probably try it. But probably not in this video. In this video I was going to just show this funny little thing that I made, because I haven't done any computer videos on this channel, and I decided finally to make one. Yeah, another rant video, but I enjoyed it. Hopefully it was fun. Yeah. Anyway, thank you for watching this video. I really hope you liked it. Soon you may see the mighty ray tracing and scrap mechanic. Finally, the thing that no one have ever done. Okay, maybe not ray tracing. Or actually, well, if I will use mods for actually like better screens, then absolutely I'll try my best if I'll have time and motivation. I'll try my best to make ray tracing, like the thing that I did in Scratch, the DDA 3D thing. Like I could try to do that using the mini quantum MQr1.1 to process the entire thing. Because the thing is, this computer will be able to actually do sine and cosine. I probably will add instructions like reciprocal for, much faster divisions. Also, I'll add square roots, so yeah. Or maybe not even square roots, maybe like, I don't know. Maybe add how do you call it? Exponents, but I'm not sure if I can make it through a lookup table because I'm going to make a big lookup table. I'm going to make like a big lookup table that will have all like 4 functions at once. So it will output 4 things, right? Let me just demonstrate it. Fine, I'm gonna demonstrate. I'm not finishing the video yet. So here I have these 2 lookup tables, right? Also the newest ones, the properest ones. Oh, that's laggy. So you can see that here we have like, this is the output, right? And this is our thing. So instead of just having this lookup table for sine, this lookup table for cosine, that's inefficient, you know? We have like the same exact input. Why would we like have completely different circuits for that, right? So it makes much more sense to just stack these outputs, and the bottom one will be cosine, this will be sine, maybe square root, maybe, I don't know, exponents, reciprocals, etc., you know? That's how I'm gonna do it. Of course, I'm making that through a script. I'm not gonna handwire that. But yeah, that hopefully will turn out great. And yes, that looks absolutely beautiful. The blue color. It's beautiful, isn't it? And here we have the green color. Ah, that's nice. Look at that. Probably the bitrate is dying right now, or maybe not. I don't know. I'm recording it basically nicely. Also, division still sucks, mate. Anyway, yeah, now for real, thank you for watching. I'll see you the next time. As link to this computer will be in this description, by the way. So yeah, if you want to watch it, or sorry, if you want to code or something on it, do something on it, you absolutely can. You can find the instruction set. Well, I'll be sending this video on the CodeMonkey's 4 channel, so or server. So yeah, you can just check it out there. To be kind of honest, if you're already watching this video, you're probably already aware of logic experts and CodeMaker 4 server, so don't need to explain that to you. Anyway, thank you for watching, and I see you next time. Goodbye.